All right, hey guys, we are on the back of the solving trig equations. We are going to be doing 4 problems today, solving using factoring, number 7 through 10. All right, so let's jump right in. Let's look at number 7 here. So the first thing we want to do is remember how this is supposed to look. So 4 cos squared x minus 1 equals 0. Well, remember, we can think of this cos squared x as its variable by itself. So we can think of this as 4x squared minus 1 equals 0. That x, remember, is cos squared x. So we basically replace the trig function just with a simple variable just for the sake of remembering how to do it. So if you look at this side, that does factor. That's a difference of perfect squares, and it cancels as 2x plus 1 times 2x minus 1 equals 0. So thinking about how that works down here, this is going to be 2 cos x plus 1 times 2 cos x minus 1 equals 0. Now remember how we can now take both of these and set them equal to 0. So again, down here, 2 cos x plus 1 equals 0. 2 cos x minus 1 equals 0. And then you just solve them. So this ends up being cos of x equals negative 1/2. And then this is cos of x equals 1/2. Now, we could do second cos, but I do want to show you an alternate way of doing it using the unit circle, because sometimes this is actually a little bit easier. So think about cos of x equals negative 1/2. Well, you're looking for where the x value of a function is negative 1/2. So if you look over here, the x value of this one is negative 1/2, and the x value of this one is negative 1/2. Because remember, cos is negative in the second and the third quadrant. So we want the two angles, 120 and 240 for this one. So the angle here is 120 degrees and 240 degrees. For the second one, where is the x value positive 1/2? Well, that's at 60 right here, and that's at 300 right there. So 60 and 300. There's actually 4 answers here because each one of these that we factored gave us 2 answers. So there's the first one. So using the unit circle can sometimes simplify the process just a little bit because you don't have to use reference angles that way. So if this makes it easier for those of you who struggle with the last one, that's great. Do it this way. That's fine. So let's look at number 8 now. Okay, so again, we want to think of each trig function as a variable. The difference with this one is we have cotangent x, but we also have a second trig function here. We have sine squared x. Oops, I wanted to make that blue. There we go. We also have sine squared x. So you can think of those as 2 different variables. So let's write that up here. Let's call cotangent x x. But let's call sine y then, just to have 2 different things. So how would I solve this? Well, the way you'd solve this would be to subtract these over. So, x minus xy squared equals 0, and then you factor it. So you have x parentheses 1 minus y squared equals 0. Make sense? So hopefully it does. That should be here, not there. All right, so let's write what that looks like down here. So we subtracted over the stuff first. So cotangent x minus cotangent x sine squared x equals 0. That's the first step. We just subtracted it over. And now we factor out the cotangent x. I'm going to draw the line. Cotangent x, 1 minus sine squared x equals 0. Now what do? Well, there's a couple ways to do it. You could set those both equal to 0 and solve it, and that would give you the correct answer. Okay? You also could remember that, let's do pink, this right here is a trig identity. 1 minus sine squared x is cos squared x. Now you don't have to do this. You could set the original one equal to 0 and solve it, and you would get the same answer. This does simplify it a little bit. All right? So now we're ready to set these equal to 0 and find the answer. So cotangent of x equals 0, cos squared of x equals 0. And this one I just got to do one last step and take the square root, which square root of 0 is just 0. So we want to find the angle where the cotangent of the angle equals 0. Now, this one does have a restriction. It's telling you that you're only looking between pi and 2 pi. So you're only looking in the third and the fourth quadrant. So let's think about where is cotangent equal to 0? Well, cotangent is cos over sine, or x over y. So we want x over y to equal 0. Well, that's going to be 0 over something. So basically, we want to know, where is the x 0? Well, the x is 0 right there. And that would be 0 over negative 1, which is 0. So that's going to be 270. So x equals, for this first one, 270. And that is the only answer. There's nowhere else that you can make x over y equal 0 in this area. Cos equals 0. Well, we already know cos equals 0 here. And that's it, right? So again, the answer for this one's also 270. You don't have to write it twice, but this one you could. But the answer for this one is also x equals 270, because that's where cos is 0. So there's only one answer here. X equals 270 degrees. All right, moving on. Now we have tan. The nice thing about this one is there's only one, so we don't have to do an x and a y. We can just do x. So let's think about what this is going to look like. It'll be 3x squared minus square root of 3x equals 0. Well, how does this factor? Well, you can take out an x, right? So 3x minus square root of 3 equals 0. So let's write that. So this is going to be tan u, parentheses, 3 tan u minus square root of 3 equals 0. So tan u equals 0. And then this one we can solve. 3 tan u minus square root of 3 equals 0. We have 3 tan u equals square root of 3. Tan u equals square root of 3 over 3. So here are my two answers. All right? So now I need to find the angles that go with those. Again, look at the restriction in the domain here. It's telling you you only want to go between pi and 3 pi over 2. So you're only looking in this third quadrant. So let's do that. So tan is y over x, right? So we want y over x to equal 0. In other words, we want the top to be 0. We want y to be 0. So in this quadrant, there's only one space where y is 0, which is right here, and that's 180. So u equals 180 degrees for this one. Now the second one, we want square root of 3 over 3. Now this one's going to be a little bit challenging, but let's only look in this quadrant. Right, we want y over x to be square root of 3 over 3. Now, let's think about this. If we want square root of 3 over 3, let's think about what happens when I divide this. If I divide y over x for this one, I have negative 1 over 2 over negative square root of 3 over 2, which is just 1 over square root of 3, right? Well, how does that rationalize? That rationalizes like this, square root of 3 over 3. You see that? So 210 is actually the answer for this one. Now remember what we did yesterday. You could have also done second tan of square root of 3 over 3. And what you would have gotten would have been 30. Right? And then you would have to remember to put it in the third quadrant because that's what it's asking for up here. So you'd put it in the third quadrant would be 180 plus 30, which is also 210. So that's another way of getting that. So number 9 was the second part's a little challenging, but that's, just do your best with it, okay? Now, the very last question here that we're going to talk about, we have sine and we have secant. Now this one looks really, really complicated. It's not too bad. All right, so let's start by rewriting the variables, or rewriting this as just x's and y's. So sine x we'll call x, secant x we will call y. So let's just rewrite this. So xy plus 2 radical 2x equals square root of 2x, right? Well, first thing we want to do is move everything to one side. So minus square root of 2 minus square root of 2. Well, what is 2 square root of 2x minus 1 square root of 2x? Well, that just gets rid of that's 2 minus 1 is just 1. So xy minus square root of 2x equals 0. And now we factor out the x. So we have x, y minus square root of 2 equals 0. Oh, that should be a plus. Fix that if you didn't. That should be 2 minus 1 is positive 2. That should be a plus. All right? So let's do that over here. Let's write what we have. So we end up with, we subtracted this one over. So it's sine x secant x plus square root of 2 sine x equals 0. Right? That's this first step. And then we factored out sine x. So sine x secant x plus square root of 2 equals 0. All right, now you set them both equal to 0 when you solve them. So sine x equals 0, secant x equals negative square root of 2 when you set it equal to 0 and subtract that. All right, so now we have to find the angles. So now the restriction tells us we're only between 0 and 180. So we're in these two quadrants right here. So where is sine 0? Well, sine is the y value, right? So sine is 0 in actually two places there. It's equal to 0 there, and it's equal to 0 there. So the angle here is 0 and 180 degrees. So that one's done. Secant, remember, is not on here, but it's the flipped version of cosine. So we want the cosine that's negative 1 over square root of 2, right? Well, if we rationalize that, negative square root of 2 over 2, so in there, which one has a cosine of negative square root of 2 over 2? So which one has an x value of negative square root of 2 over 2? Well, that's just this one right here, right? 135. So it's going to be 135 degrees. Okay, so those are those 4 questions. Hopefully you were able to work your way through this. I know it's challenging. I do want you to try a couple of the homework problems just to make sure. Use your answer key as a guide. So why don't you do number 5, 7, and 8. Try number 5, 7, and 8 in your homework. And yeah, let me know if you have any questions. All right, thanks, bye.